This example asks us to graph two functions on the same set of axes, but to create two different t-charts to do this. For the first function, I'm going to create a t-chart. Instead of saying y equals square root of x, I know that g of x represents y, but I'll leave it so that we can distinguish which function we're working with. On square root functions, it's important to pick the value where the square root function starts. In other words, if we have g of x equals the square root of x, what is the first number that we're able to plug in for x so that it's legal to take the square root? In other words, if I choose -1 for x, that's an invalid choice because I can't take the square root of a negative value. If I choose 0 for x, I know I can take the square root of x. So 0 would be the first value that I can take the square root of. So g of 0 equals square root of 0, which is 0. So my first ordered pair would be the ordered pair 0, 0. Now choose values that are easy to take the square root of. So in this case, I can then choose 1. G of 1 equals square root of 1, which equals 1. So I'd have an ordered pair 1, 1. The next easiest value to take a square root of would be 4. G of 4 would equal the square root of 4, which equals 2. So we have the ordered pair 4, 2. For now, we're going to let that be the end of the t-chart for this particular function. If we need to choose more values later, we can. Now let's make a t-chart for h of x. I've done g of x in blue. I'll do h of x in red. So we have x's. We have our function h of x equals square root of x minus 3, and then we'll have our ordered pairs x, y. Now, in this particular situation, be careful because it's not just x underneath the square root. We're taking x and we're subtracting 3. So for example, the first x value that I used above was 0. That wouldn't work in this particular function because if I plug 0 in where x is, I'll get 0 minus 3, and 0 minus 3 is a negative number that I can't take a root of. On here, the first value that I could take a root of would be whatever value of x would make the value underneath 0. Well, if I plugged 3 in where x is, 3 minus 3 underneath would be 0, and I can take the square root of 0. So the first x value for this function that I'm wanting to choose would be 3. So h of 3 equals square root of 3 minus 3, which equals square root of 0, which equals 0. So this ordered pair is 3, 0. Now, this gets a little tricky because of the x minus 3 underneath. The next value that I know how to take a square root of is 1. What value for x would I need to plug in so that x minus 3 was 1? Well, if I plugged in 4, then that would give me 1 under the root. So I would use 4 as my next x value. H of 4 equals square root of 4 minus 3, which equals square root of 1, which is 1. So this ordered pair would be 4, 1. Let's choose one other value. The next value that I easily know how to take the square root of would be 4. What x would I subtract 3 from and give me 4? Well, that value would be 7. So h of 7 equals square root 7 minus 3 equals 7 minus 3 is 4. Square root of 4 is 2. the first function, g of x, was easier for me to choose x values for. I get to choose x values, which means that I want to choose values that are convenient for me. Really, the only guideline that I'll give you as far as something that's necessary is that you make sure that you choose an x which is the first x that you may take the root of. So in the case of g of x, I must choose x is 0 so that I will have the start of my graph where it needs to be. In other words, 0 is the first thing that I can take the square root of. In the h of x function, I must choose 3 as my first value of x because plugging 3 in where x is gives me square root of 0, which is the first value that I can take the root of. From there on out, I'm just going to say make it easy on yourself. In other words, if you choose an x value that makes it hard to take a square root, adjust your x value. So in my case, when I was looking at the h of x example, I chose 4 and 7 because when I plugged in 4 and 7, I was able to get square root of 1 in the first situation and square root of 4 in the second situation, which made it easy for me to get ordered pairs. Now, I'll go and I'll plot these ordered pairs, and the instructions said do it on the same set of axes. And I'm actually going to do my graph right over here just to make it easy for us to be able to see. Now, looking at the ordered pairs that we have, the largest x value that I'm going to have is 7. So I'm going to go ahead and go out to 7. So 1, 2, 3, 4, 5, 6, 7. Now, the largest y value that I've received is 2. So I'm going to go up 1, 2. I'm going to graph g of x in blue. G of x started at 0, 0. The next ordered pair was 1, 1. The next ordered pair was 4, 2. We will learn later that a root function has a somewhat one-sided shape. It's kind of like a half parabola turned on its side. This one started at 0, 0. It shoots out to the side in a curve. Now graph h of x. So we'll plot the ordered pair 3, 0. That's the first point on our graph. We'll plot the point 4, 1. And then we'll plot the point 7, 2. And we see that the shape is similar, which should be the case, but it's actually below the other graph that we've drawn.